Alright, big idea number 4, the distance formula and the Pythagorean theorem. Okay, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of that whole thing. Okay, so that's the distance formula. It's also on the NISA reference sheet, so feel free to look at that and use that often. Okay, so you just need 2 points to find the distance formula. The Pythagorean theorem is a squared plus b squared equals c squared. Remember, c is your hypotenuse or your longest leg. So the vertices of a triangle are a is 0, 1, b is 4, 4, c is 7, 0. Find the lengths of the sides. So if I wanted to find the distance between a, b, I would use the distance formula. Okay, so x1 minus x2, so or x2 minus x1, so 4 minus 0 is 4 squared plus, and then 4 minus 1, so 3 squared. So I have the square root of 16 plus 9, which is the square root of 25, which is 5. Okay, so that's AB. I'm going to make that a little bit smaller so I have some room to work with. And then you'd want to find AC. Okay, AC, so the square root of x2 minus x1, so 7 minus 0 is 7 squared plus 0 minus 1 is negative 1 squared. So you'd have the square root of 49 plus 1, which is the square root of 50. Now there is no square root of 50, but I do need to simplify my radicals. So again, you can do a factor tree. So you got 25 and 2, 5 and 5, so you have a pair of 5s. So that simplified would be 5 square root of 2. Okay, so the distance between A and C is 5 square root of 2. Make that a little bit smaller now so I can finish the last one. And the last one is B, the distance between BC. Okay, so you'd have the square root of 7 minus 4 is 3 squared plus 0 minus 4 is negative 4 squared. So you'd get the square root of 9 plus 16. So you get the square root of 25, which is 5. Remember, anything negative squared is still positive. Okay, so that is the distance formula. Find x on number 1. Okay, so we want to figure out, using the distance formula, what x would be. So if I know that on number 1, this entire bottom or base is 48, okay, and each side is 46, or excuse me, 26, then we know that this is the midpoint. Okay, which means this length is half of 48, which is 24. So I would know that x squared plus 24 squared equals 26 squared. Okay, so you get x squared plus 576 equals 26 squared, which is 676. Subtract that from both sides. So x squared equals 100, square root of both sides, so x would equal 10, because the square root of 100 is 10. Alright, number 2, we know that the entire thing is 2, and since both of those sides are the same, that means each of these sides is 1. So we'd have x squared plus 1 squared equals 3 squared. So x squared plus 1 equals 9, minus 1 from both sides. X squared equals 8. Take the square root. Well, there is no square root of 8, but if I did a factor tree, I'd have 4 and 2, 2 and 2, so a pair of 2's. So I have 2 square root of 2. Okay, so make sure you're simplifying your radicals. Last one, the coordinates of the vertices for rectangle ABCD are 2, 4, 6, 10, 9, 8, and 5, 2. What is the length of the diagonal? Okay, so you can either, if you think of this as ABCD, BCD, you could either do A to C or B to D, because if you remember about rectangles, the diagonal's the same, so you just have to find the distance of one of them. So let's just find the distance of AC. So you have the square root of, remember we're using these 2 points, so we'd have 9 minus 2, which is 7 squared, plus 8 minus 4, which is 4 squared, so you'd get the square root of 49 plus 16, which is the square root of, let's see, 55, 65, and then you got to think of any perfect squares that would go into 65. if you did a factor tree over here, you'd get 5 and 13. Nothing goes into that, so your square root of 65 would be your answer. Okay, so that's the distance formula and the Pythagorean theorem. Go ahead and do the independent practice for that.